Can bring your day to a grinding halt better than a blue screen of death. Your system comes to an immediate halt, and you usually see a blue screen or some other error message on the screen. This is happening when you're starting up your system or shutting it down. It might be related to bad hardware, you might have bad drivers, or there might be an application causing a problem with all of these. If you're running in Mac OS, you might be getting the Apple Pinwheel or the spinning beach ball. In those cases, it may be that an application is trying to access a resource that's unavailable, or there may be resource contention with multiple applications trying to access it simultaneously. In Windows, you could try rolling back to a previous configuration with the last known good setting. You could also choose a system restore to a previous point in time, or you can choose the specific driver that you think might be causing the problem and roll back to a different version of that driver. You can do many of these using safe mode to try to avoid some of the startup problems you're having with the blue screen of death. If you think the problem might be related to hardware, it might be worthwhile to open the cover and try reseating all of the components and all of the cables on the inside of your computer. You also might want to try running some hardware diagnostics. The manufacturer might be able to provide you with hardware diagnostics, or they might be already built into the BIOS of your computer. If you start your computer and you get a very abrupt can't find the operating system or operating system missing, then you have a bigger problem on your hands. This could also occur because you've installed an additional operating system and you've overwritten the original bootloader that was configured on your computer, and now no bootloader is installed and no operating system can be found. This might also occur because you've left some media in a boot drive, so make sure you don't have any type of optical media or USB storage device connected to your computer and try rebooting again. In Windows, you could also run a startup repair. This is going to not only identify where your operating system is, it can also resolve any problems with your bootloader. If you think the problem might be related to the boot configuration database or the BCD in your Windows system, then you can always repair this yourself from the command prompt of your operating system. I'll remind you later in this video how you get to this command prompt, but once you're here, you can run the command bootrec/rebuildbcd to rebuild that boot configuration database. If you start up your computer and you get this screen, the Windows Error Recovery screen, it will tell you that Windows did not shut down successfully. If you think you know why Windows did not shut down successfully, then you may simply want to choose Start Windows normally and continue with this process. If this is something that is occurring often and you aren't quite certain why this might be happening, it might make more sense to launch Startup Repair and fix whatever issue might be involved with this particular problem. You can also run this by pressing F8 when the system starts, or simply choose Launch Startup Repair whenever the Windows Error Recovery screen is shown. If you start your computer and you're not getting any type of graphical user interface, you're not seeing a login dialog box, you might not be getting any screen at all, then you probably have some type of driver corruption or some problem with files that are part of the operating system. One of the things you can try is to start in VGA mode. While Windows is booting, you can press the F8 key and choose to start in VGA mode. Once the system is started, you might want to try running SFC. This is the system file checker that will check all of your operating system files and make sure that they're all working properly. This is something you can usually run from the recovery console at the command prompt. You might also want to consider updating your drivers. You can do this in safe mode, especially if your problem happens to be with a video driver that's causing the screen to go black when you try to start your system. If you're Windows 8 or 8.1, you might also try running a repair or refresh, and you could, of course, also recover from backup regardless of what operating system you're using. Startup Repair is a Windows utility that can solve a number of problems. If you start your computer and you get a message that says missing NT loader, that means that the main bootloader in Windows is missing. This is usually because you have a removable storage device like an optical drive or a USB drive connected, and it's trying to boot from those devices rather than your main storage device. You can run Startup Repair to automatically fix these files, or you can replace the files manually and restart your system. Another good reason to run Startup Repair might be because you're getting a message that says missing operating system. This is often because your boot configuration data, or BCD, might be incorrect. You can, of course, run Startup Repair to automatically repair the BCD, or you can manually configure the BCD yourself. And if your system is constantly starting up in safe mode instead of starting in the normal Windows mode, then you absolutely want to run Startup Repair to try to resolve what issue may be preventing Windows from starting normally. To get to the Windows Startup Repair, you need to get to the advanced boot options. You get to those by pressing F8 before Windows loads. If you have a boot manager like I do, you can press F8 while boot manager is shown, or simply press F8 before the Windows logo appears. When you press F8, you get the advanced boot options screen. And from here, you have options to repair your computer, you have safe mode options, and many other options when Windows starts up with Windows 7. I'm going to choose repair your computer, and it's going to start the Windows operating system into a recovery mode that allows me to choose a number of different
should be able to use the command line to perform operations in Linux, search for files, create and manage files, install and update software. Linux system administrators spend a significant amount of their time at a command line prompt. They often automate and troubleshoot tasks in this text environment. There's a saying, graphical user interfaces make easy tasks easier, while command line interfaces make difficult tasks possible. Linux relies heavily on the abundance of command line tools. The command line interface provides the following advantages. No GUI overhead is incurred. Virtually any and every task can be accomplished while sitting at the command line. You can implement scripts for often used or easy to forget tasks and series of procedures. You can sign into remote machines anywhere on the internet. You can initiate graphical applications directly from the command line instead of hunting through menus. While graphical tools may vary among Linux distributions, the command line interface does not. A terminal emulator program emulates or simulates a standalone terminal within a window on the desktop. By this we mean it behaves essentially as if you were logging into the machine at a pure text terminal with no user. On your own systems, you may need to set up and enable sudo to work after you've logged in and the relative
backwards.
permissions. Understanding file permissions is crucial for maintaining security and proper access control in any Linux environment. So let's get started. First, let's talk about ownership. In Linux, every file or directory is assigned 3 types of owners: the user, the group, and others. The user is the owner who created the file or directory. They have the most control over it. The group consists of users who share the same permissions to access the file or directory. Others are users who are neither the owner nor members of the group. They have the least control. To manage access, Linux uses 3 types of permissions: read, write, and execute. Read allows a user to open and read file contents. Write allows modifying or editing file contents. Execute allows the file to be run as a program. Permissions are represented in 3 ways: binary, octal, and string representation. Consider the permission RWX. In binary, it is 111, where each bit represents a permission. Read is 1, write is 1, and execute is 1. In octal, this is represented as 7, with read being 4, write being 2, and execute being 1, added together. In string representation, it's simply RWX. Let's consider a practical example. Suppose you have a file where the owner has full permissions, which is RWX and translates to 7. The group can read and write, which is RW- and translates to 6. Others can only read, which is R-, and translates to 4. In octal, you could represent this as 764. Using the chmod command, you can set these permissions like this: chmod 764 and the file name. The owner can read, write, and execute the file. The group can read and write, and others can only read. Now let's talk about special permissions bit: setuid, setgid, and the sticky bit. These provide additional control over files and directories. The setuid bit, when set on an executable file, allows it to run with the permissions of the file owner, not the user running the file. This is useful for tasks that require higher privileges. For example, the password command, which changes user passwords, has a setuid bit set. This allows regular users to change their passwords, which requires modifying sensitive system files. When the setuid bit is set, the execute bit for the owner shows as S. The setgid bit can be set on files or directories. On the executable file, it allows the file to run with the permissions of the group that owns the file. On a directory, it ensures that the new files and directories created within the directory inherit the group ownership of the directory. This is useful for shared project directories, ensuring all files created within have the same group ownership, allowing team members the necessary access permissions. When the setgid bit is set, the execute bit for the group shows as S. The sticky bit, when set on a directory, ensures that only the file owner, the directory owner, or the root user can delete or rename the files within the directory. This is commonly used on directories like temp to prevent users from deleting each other's files. When the sticky bit is set, the execute bit for the others is shown as T. To set these special permissions, you can use the chmod command with specific symbols or numeric representations. For example, let's say you want to set the setuid bit on an executable file named important script, along with the typical permissions of read, write, execute for the owner, the read and execute for the group and others. In this command, 4 set the setuid bit, 7 gives the owner read, write, and execute permissions, and 5 gives the group and others read and execute permissions. Understanding these permissions and special bits is essential for managing access and ensuring security in your Linux environment. Correctly setting file permissions and special bits can prevent unauthorized access and accidental modifications, safeguarding your data and ensuring smooth collaboration. That's it for today's video on Linux.
Every journey through the world of troubleshooting ends the same way. Some things are easier to troubleshoot than others. And also, if you and I have been working on like one large network and we know it like the back of our hand, it's a lot easier to troubleshoot because we know what the subnets are and the interfaces involved. Where, on the other hand, if we go to a brand new network or we're doing consulting, it may take some warm-up time to get used to and to figure out where everything is on that specific customer's network. And when we're doing troubleshooting, again, whether it's our own network that we know really well or it's a new network that we were just introduced to, if we have a certain process or methodology for troubleshooting, we can apply that methodology across the board. So let's have some fun with this. We'll put an overview of the high-level steps regarding a troubleshooting methodology, and then as we proceed together, we'll actually apply those steps as we troubleshoot together a network. So at the very beginning of this troubleshooting process, it would be to identify the problem. Case in point, let's imagine that the user who's sitting at this computer right here, PC10, calls the service desk or the help desk or whatever they're calling it in your organization, and they say, yeah, I've got a problem. And then the service desk says, okay, tell me more. And if the user says, well, I can't really tell you anything, well, we have to kind of, narrow down what the problem is or at least get what the symptoms are. And that's why one of the very first steps is to identify the problem. So with the identification of the problem, the user may say, I can't access the internet. Or they may just say the network is down, at which point we would ask some additional questions. So let's imagine this user says that I can't access anything on the internet. That would fall into this category of identifying the problem is that this user who normally can access the internet can no longer access the internet. The second step would be to establish a theory regarding why that might be happening. And so by leveraging a topology like this, we could ask ourselves a few questions. For example, is this computer powered on? If the computer is powered on, does it have an IP address? And if the DHCP client, did it get the right information regarding a default gateway and the subnet and all that good stuff? And then regarding this port, is this port on the switch, is it associated with the right VLAN, which is VLAN 10? And regarding the trunking, that's going down from the access layer switch to the core, is trunking working and is VLAN 10 being allowed? And then from the default gateway's perspective, regarding VLAN 10, who's acting as the default gateway? Is it Core 1 or Core 2? Or are they using a first hop redundancy protocol? And if so, which one of these two devices is acting as the active device? And does that device, acting as the default gateway, have a route out towards the internet? In simple terms, does it know how to forward? And the same thing would hold true for this router, and then this connectivity to our service provider. And also because we're using RFC 1918 addresses, perhaps network address translation is failing or isn't implemented correctly. So if this user at PC10, by doing a few tests, we verify that it can ping its default gateway, and if this device in VLAN 10 up here at headquarters can ping devices out here at Site 2 and Site 3 and has reachability there, that can help identify what is working, and then we can establish a theory about what may be specifically causing the problem. And then once we've narrowed it down to what we think it might be, and then the third step is to test, which is to basically go in and prove your theory. If we think the problem is with router 1, or if we think the problem was with the multi-layer switch, or we think the problem was with the access layer, we want to do some testing to validate that what we think may be the problem really is causing the problem. And then once we've narrowed it down and verified it, we then want to go ahead and solve the problem. Now, solving the problem in an organization also has many steps involved with it. Let's list a few of those as far as the solution to this network connectivity problem that the user is having out to the internet. And let's also imagine, based on our testing, that we believe it's an issue with address translation, which could be NAT or PAT, but definitely needs to happen at some point before that traffic goes out to the internet. So if we've done some testing and we've narrowed it down that it is an address translation issue, regarding solving that, we want to create a game plan on exactly how we are going to solve that problem. Perhaps with network address translation, the NAT device was set up to support VLAN 20 with the 10.120 subnet and other networks like this over here at Site 2 and Site 3, but maybe perhaps not including the 10.110 subnet. So we'd want to make a plan to correct that, and also in corporations, that's going to involve going through change control if we're going to make a configuration change. And then with the authorization from the change control board, then we're going to go ahead and implement the change. And then when we've implemented it, we also want to verify that it's working. And that verification would involve a few things. Number one, that we now have connectivity from this PC out to the internet. Also, we'd want to verify that we didn't make any other changes that would negatively impact our environment. Like, we want to make sure that everything else still functions as well. VLAN 20 and the other sites, everybody can still forward out to the internet. And then we'd also want to make sure we document the solution, what we did, how we did it, and if we change the topology in some fashion, we'd want to include that update in our documentation. So the documentation of what was done and also the topology, if there's been updates, that's super important because let's say 3 or 4 days go by and we have yet another problem and we think, oh, I wonder if what we changed here injected additional problems into the network. So we could go back through our paper trail and identify what happened, when it happened, what was changed. And that can help speed up our troubleshooting, because a lot of times there are cabling issues and physical issues and so forth. But a lot of times when something breaks on the network, when something stops working, it's quite often due to the last change that was made. And so if we go back and take a look at the last change or two, that can help us reduce our troubleshooting time by either confirming that what was done is not impacting our current problem, or by verifying that what was done indeed is impacting our current network. And then the last step here is to go ahead and repeat this process for the next problem. So the next service call that comes in, the next issue, the next problem, again, we're going to follow this log.